Hello everyone. Today we're going to look at applications of quadratic functions. So basically we're going to take the quadratics that we've been working with on finding vertex and all of that information and putting it into context of word problems and real world situations. So in this particular example, we are given that a football player throws the ball which follows a parabolic path. The height of the football in feet, so height of the football in feet can be modeled by f of x is equal to negative 0.005 x squared plus 2x plus 5, where x is the ball's horizontal distance in feet. So that's just so you understand our axis here. X represents the distance, the horizontal distance that the ball travels, and y represents the height of the football. Now it's asking here, what is the maximum height of the football and how far from its release does it occur? Whenever it's asking for a maximum or a minimum, that means that we are looking for the vertex. Now remember, keep in mind that your vertex is h, k. And in this particular example, h is the x value, which represents the horizontal distance. And k is the y value, which will be the height of the football. And in this case, the max height. So if I want to find the maximum height and how far from its release does it occur, we're looking for the coordinate of the vertex. Because if I know the coordinate of the vertex, then I know exactly how far the ball traveled before it reached its maximum height. So as a reminder, in order to find h, we are going to do negative b over 2a. And in order to find k, we plug in h into f of x. So here we go. Let's do h. So negative b, which would be negative 2, divided by 2 times a, which is negative 0.005. If I work this out, negative 2 divided by 2 times 0.005, we get negative 0.1. And when we divide negative 2 by negative 0.1, we get 200. And remember that this h represents the horizontal distance in feet. Now let's get the k. K is once we plug in 200 into the function. So we're looking for f of 200. So that would mean that we have negative 0.005 times 200 squared plus 2 times 200 plus 5. Let's work this out. Negative 0.005 times 200 squared, which is 40,000, plus 400 plus 5. Negative 0.005 times 40,000 is equal to 200, negative 200, sorry. And negative 200 plus 400 plus 5 is equal to 205. So this is my maximum height, which is 200 feet, which occurs when the ball has traveled 200 feet. Now let's go to find the horizontal distance the ball travels before it hits the ground, and we're going to round to the nearest foot. So in order to find the horizontal distance that the ball travels before it hits the ground, that means that when the ball hits the ground, f of x would equal to 0. Because think about it, if the ball is on the ground, the height of that ball is 0 because it's on the ground. So therefore, in order to solve for when f of x is equal to 0, we're going to set the quadratic equal to 0. And then solve for x. Since this is just a regular quadratic equation, we can solve this by using the quadratic formula. And as a reminder, the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And when we do this, the quadratic formula, what it solves for is the x-intercepts, because that's when y is equal to 0, is when we have an x-intercept. So let's go ahead and plug in these numbers. We have negative b, so negative 2, plus or minus the square root of b squared, so 4, minus 4 times a times c all over 2 times a. If we continue to work this out, we get negative 2 plus or minus the square root. Now, I already worked this out. 4 minus 4 times negative 0.005 times 5 is 4.1. And this is over negative 0.01. Now, the square root of 4.1 is 2.02. So negative 2 plus or minus 2.02 all over negative 0.01. Now, the quadratic formula in this case gives us two answers, and that's because of this plus or minus. So in order to get those two answers, you would first do the plus and then you would do the minus. So negative 2 plus 2.02 is 0.02, and we're going to divide that by negative 0.01. And then to get the second answer, we do negative 2 minus 2.02, which is negative 4.02, and we divide by negative 0.01. So when we actually do this division, 0.02 divided by negative 0.01 gives us negative 2.5. And when we divide negative 4.02 by negative 0.01, we get a positive 402.5. Now keep in mind that these are our x-intercepts, but what they're supposed to represent is the horizontal distance. So to figure out which one of these is actually correct, there is no such thing as a negative distance. So this is not the correct answer. Instead, our answer is 402.5 feet. But it does say to round to the nearest foot, so the ball travels a total of 403 feet. Now, when it comes to graphing, what information from the previous parts of the problem are useful in terms of graphing? Well, first of all, we have the vertex. So we can go ahead and plot that vertex, 200, 205. So we would just go right above the 200. Let's just estimate about right here. Then we also have our two x-intercepts, which we can use to plot on the x-axis. So negative 2.5, even though it is not a valid answer for this particular word problem, it's still useful in terms of the graphing bit. So we would go to negative 2.5 and then 402.5, which is a little bit past the 400. Again, we are estimating these dots. And since we have these three dots, we can just connect them. And this would be the parabola that models the curve of the football. Let's look at another example. Once it loads. Here we go. The equation for a ball that is launched from a platform is given by the equation h of t is equal to negative 4.9 t squared plus 19.6 t plus 58.8, where h of t is the object's height in meters above the ground and t is the time in seconds. So I like to underline these things so I don't forget my units, I don't forget what everything represents. So h of t is height in meters and t is time in seconds. And we're looking for when does the ball hit the ground. So we are solving for t. Now keep in mind that the object will hit the ground, or object ball is going to hit the ground when h of t, the height of the ball, is equal to 0. So just like the previous problem, we're going to take the quadratic equation and make it equal to 0. Oops, forgot this t. There we go. Now, since we're trying to solve for the time, we can certainly use the quadratic formula just like we did in the previous example. However, sometimes what I like to do is check to see if the number that is attached to the t squared or the x squared or whatever squared is divisible by every single term. Now, negative 4.9, I'm sorry, 19.6 is divisible by negative 4.9, and so is 58.8. So what I'm going to do is I'm going to factor negative 4.9 out of this quadratic. And when I do so, I get t squared minus 4t minus 12. So basically, I divided negative 4.9 from every term and I moved it outside of the parentheses. And the reason why I did that is because now I have a quadratic equation that can be easily factored. So negative 4.9 and then t squared minus 4t minus 12 can be factored to give you t minus 6 and t plus 2. As a reminder, how to factor, you take the two numbers that multiply to give you negative 12 and add to give you negative 4. The two numbers would be negative 6 and 2. So basically, I would open my two parentheses and I would put t minus 6 and t plus 2 because negative 6 times 2 is negative 12 and negative 6 plus 2 is negative 4. And that would give me my factors. Once you have your factors, what you do is you take each individual factor, so t minus 6, you make it equal to 0, and t plus 2, you make it equal to 0. This negative 4.9 will not affect your answer because there is no t attached. So you take only the factors that have your variables, and those are the ones that you make equal to 0. And now we solve for t. So here we're going to add 6, and we get t is equal to 6 seconds, since t is time in seconds. And then here for t plus 2, we subtract the 2, and we get t is equal to negative 2 seconds. Now, of course, there's no such thing as negative time, so this is not a valid answer. And my only answer would be t is equal to 6 seconds. So the ball will hit the ground when t is equal to 6 seconds. Now let's try out this last one here. An object is launched directly upward. The equation h of t is equal to negative 16t squared plus 64t plus 80 models the object's height in feet at time t in seconds. What will be the object's maximum height, and when will it attain this height? So again, we see this word maximum. That means we need to find the vertex. Now, in this example, we can definitely just use the quadratic equation that is given. But what I did is that I factored a negative 16 out of this quadratic. And the reason I do that is because then it'll keep my numbers smaller. So this would give me t squared minus 4t minus 5. Again, the reason I did this is because now when I try to find the vertex, A is 1, B is negative 4. So my numbers are much smaller and it's easier to do. But however, if you don't want to factor, that's fine. You can still use the quadratic equation that's given and find the vertex using these numbers here. That would still give you the same answer. So remember that h is found by dividing negative b over 2a. In this case, negative b would be a positive 4 over 2 times a, which is 1. 4 divided by 2 is 2. So this represents a t value, since remember that h is the x, and in the x here is not x, but t. So at 2 seconds, the ball will reach its maximum height, or rather the object, whatever. So now we're going to find k, which is when we take 2 and we plug it into the function. So we're looking for h of 2. And that would be negative 16 times 2 squared plus 64 times 2 plus 80. 2 squared is 4 times negative 16 is negative 64 plus 64 times 2, which is 128 plus 80. And if you add all of this together, we get 144. And this is the height, which is feet. So the object will reach a maximum height of 144 feet at t is equal to 2 seconds. Now, another useful tool for quadratics is that we can use it to optimize a function. So optimization is simply when you are either maximizing or minimizing a quantity. So some examples of optimization is when you maximize profits or minimize costs or maximizing area and volume. So we're going to look at how to do so using our quadratics. Now, if you think about it, optimization, since it involves the process of maximizing or minimizing, this means that we are going to work heavily with the vertex, since the vertex is where you have the maximum or minimum. So I put some steps here that we can follow, and we're going to start with a very basic example. It says here, among all pairs of numbers whose difference is 10, find a pair whose product is as small as possible, and what is the minimum product. So the first part is to read the problem carefully and decide which quantity it is to be maximized or minimized. Here we are minimizing a product, and it's of two numbers. A product is the answer you get once you multiply two numbers. Now we don't know what those two numbers are, so we're going to just say x, y. I'm going to multiply two numbers together, and what I'm trying to do is minimize. Then we're going to write the equation of the quantity that is to be maximized or minimized, which is what we just did. For step 3, we're going to write the equation from the given constraint to rewrite the previous equation in one variable. A constraint is basically some other piece of information that limits your two numbers. So when we look at this word problem, we are told that those two numbers have a difference of 10. Difference is when you subtract. So that means that x minus y will equal to 10. This is my constraint. And what we do with this equation is we use it to solve for one of the variables. So let's just say I decide to solve for x. Now you can choose to solve for x or y, it does not matter. I'm just going to solve for x because I would just have to add the y. So from here, I would get the equation x would equal to 10 plus y. What I do with this is I take what x is equal to and I plug this into the x of the equation that I'm trying to minimize. So basically, I'm substituting what x is equal into the equation I'm minimizing. So 10 plus y times y. This is what I'm trying to minimize, my product. Now, when I multiply this together, I would get 10y plus y squared. And if you write it in standard form, that's basically y squared plus 10y. Now, since I'm trying to minimize this, look at this quadratic. This quadratic is going to face upwards since a is a positive number. And when it's facing upwards, we indeed have a minimum. So if I find the vertex of this quadratic here, that's going to give me that minimum value. So first I'm going to solve for h, which is negative b, so negative 10 over 2 times a, which is 1. And that's going to give me negative 5. And then this, remember, is not the actual minimum. The minimum is the k. So now I'm going to plug this back into what I'm trying to minimize. So negative 5 squared plus 10 times negative 5. And that is going to equal to 25 minus 50, which is equal to negative 25. So this is my minimum product. Now, additionally, this particular question asked to find the pair of numbers. This first number here that you found, remember that this represents y, since that is the variable in what I was minimizing here. So in order to find the second pair of numbers, we take the constraint and we plug it in for y. So x minus negative 5, so plus 5, is equal to 10. And if I solve for x, I get that x is equal to 5. So my pair of numbers is equal to 5 and negative 5. So these are my final answers, my minimum product and my pair. Let's look at another example where we are maximizing area. So I put here that it's useful to draw a picture for these kinds of problems, and that's what we're going to do with this once we read it. You have 100 yards of fencing to enclose a rectangular region. So I'm going to draw my rectangle. Find the dimensions of the rectangle that maximize the enclosed area. And what is the maximum area? Now, for this rectangle, if I call this x, then this is also x. And if I call this y, then this is also y, based on the properties of a rectangle where opposite sides are equal to each other. Now we are trying to maximize area. Now how you find area of a rectangle is you multiply the length times the width. So x times y. This is what I am maximizing. Now my constraint comes from the other given information. We are told that we have 100 yards of fencing to enclose the rectangular region. 100 yards of fencing means that I have enough fencing to cover this side and this side and this side and this side, basically the perimeter of the rectangle. So the perimeter of the rectangle is going to equal to 100 yards. So that means if I add everything together, x plus y plus x plus y, that would give us 2x plus 2y, and it's going to equal to 100. This is my constraint. So we use the equation that actually equals to a number to solve for one of those variables. In this case, I'm going to choose to solve for y, just because I like to have my equations with x's. So I'm going to subtract this 2x over. So I have 2y is equal to negative 2x plus 100. I just reversed the order, so it's in standard form. And then I'm going to divide everything by 2. So y is going to equal to negative x plus 50. Since I have this equation for y, we take this and we plug it back into the equation that we're trying to maximize. So the area is going to equal to x times y, which is negative x plus 50. We distribute, and we get negative x squared plus 50x. This is my quadratic. it is a negative a, so that means it's going to face down. So we indeed have a maximum, which is what I'm trying to do. So in order to find the maximum, we are going to first find the vertex. So h, which I'm going to start writing what the variable is so that way we don't lose track. H in the case of this quadratic is equal to that variable, which is x. And that's going to be negative b, so negative 50 divided by 2a, which is negative 1. Negative 50 divided by negative 2 is a positive 25. So actually what this tells you is one of those dimensions that we're trying to solve for. Since we already got one dimension, now we need to figure out the maximum, and then we can figure out the other dimension. So we'll just keep this in mind for later. Now we're going to solve for k, which is where you take this 25 and you plug it back into the equation that we had originally for area. So negative 25 squared plus 50 times 25. 25 squared is equal to 625. So, and then we have this negative here, so negative 625 plus 50 times 25, which is equal to 1,250. And when we add these together, we get 625. This is my maximum area, so we have to make sure that we include the units. My units is yards, and area is always squared. So this is the max area. Now to solve for the dimensions, we have 1, which is 25. That's the x. So we can come to this equation here that's solved for y and plug it in to solve for the other dimension. So y is equal to negative x, which is 25, plus 50. And negative 25 plus 50 is 25. So my dimensions would be 25, which is the x, by 25 yards, since those are my units. This x here just means by. If you prefer, you can just write by 25 yards. Let's try another one. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and width of the plot that will maximize the area and what is the largest area that can be enclosed. So let's draw a picture. We are told that we're going to put this rectangular plot along a river. So this is my river, and this is my rectangular plot. Now the fencing is only going to go along the sides here, but not along the side of the river. So I'm going to call this y, and this one x here. So now we are trying to maximize the area once again. The area of the rectangle, even if you don't enclose that side, is still the same. Area is base times height, or length times width, so xy. What's going to change here is my constraint. The 200 feet of fencing to enclose this rectangular plot is only going to be applied to these three sides. So for the perimeter, it would just be x plus 2y, and it's going to equal to the 200 feet. I'm just going to underline feet so I don't forget my units. This is my constraint. So I'm going to use this to solve for either variable. In this case, it's easier to solve for x than to solve for y, so we don't have to divide the two and have fractions. So I am going to subtract this 2y. So x will equal to 200 minus 2y. Now remember, we take this and we plug it into the equation that we are trying to maximize. So my area is going to equal to x, which I'm going to write it now in standard form, which is negative 2y plus 200 times y. Distribute, and we get negative 2y squared plus 200y. Now, since I'm trying to maximize, we're going to find the vertex, so h, which in the case of this equation, since it's in terms of y, is going to equal to the value of y, which is negative b, so negative 200 over 2 times a, which is negative 2. This will give me negative 200 divided by negative 4, which is equal to 50. So this is the value of y. That is solved. But now we're going to plug this back into my equation for area to get the maximum area. Let's do that over here. So max area, which is equal to k, is going to be negative 2 times 50 squared plus 200 times 50. 50 squared is 2,500 plus 200 times 50 is 10,000. Negative 2 times 2,500 is negative 5,000 plus 10,000, which is equal to 5,000. This is my maximum area, and our units would be feet, since that's my units. And remember, area is squared. So this is my max area. Now to finish solving for my dimensions, I already have that y is equal to 50. So now I need to solve for x, which I can use this equation here that's already solved for x. So x is equal to 200 minus 2 times 50. So x is equal to 200 minus 100, which is equal to 100. So my dimensions would be 50 by 100 feet. Now it doesn't matter if you write 50 by 100 or 100 by 50, it's going to mean the same thing. So this would be my dimensions. Now I just noticed that another way you could have done this, since you have solved for y here, you could have taken that value for y and plugged it in here for x and solved for x. And then once you have solved for x, you have your dimensions. And then you could have taken those two dimensions, 50 times 100, and multiplied it to give you that 5,000 feet. Whatever you feel most comfortable doing is fine. Let's look at the last example. Let's say we are building two cute little rectangular gardens, one for flowers and the other for spices. We want to build them adjacent to one another. Adjacent means next to each other, and against the back of our house, with a fence around it. But we only have 120 feet of fencing available. What would be the maximum area that can be enclosed? So if we're trying to build two rectangular gardens that are adjacent, that means that they are touching. So it's like this. So when you see adjacent, that means that one of the sides here are shared. Now I am going to label each side of these rectangles. So I always call my horizontal sides x, and then this is x, since they're going to be the same. This is x, and this is x. Then all of the vertical sides here, I call that y, and this one is shared, and this one here. So this represents this situation. What we are trying to maximize here is the area. So area is going to equal to the base times the height. Now the base of the whole thing is x plus x, so 2x. And then the height is just y. So my area would be 2x times y. Now we only have 120 feet of fencing available for all of my fence. So that's again my perimeter. So you just basically add all of this together. So x plus x plus x plus x, which is 4x plus y plus y plus y is 3y, and we're going to make that equal to 120. Now you can choose to solve for whichever variable you like. I'm going to solve for y. So subtract the 4x over, and we get 3y is equal to negative 4x plus 120, and then we divide the 3. And we had to divide everything by 3. So we end up with y is equal to negative 4 over 3x plus 40. So now, just like the previous examples, we're going to take this y and we're going to plug it into the equation that we're trying to maximize. So a is equal to 2x times y, which is negative 4 over 3x plus 40. Distribute, and we get negative 8 over 3x squared. Because remember, when we multiply numerator with numerator, denominator, denominator, and then x times x, which is x squared, plus 2x times 40, which is 80x. Now I'm ready to find the vertex. So h is equal to, in this case, x, which is negative b, so negative 80, over 2 times a, which is negative 8 over 3. Now I know that we don't like this, right? So let's work with the denominator first. This is negative 80 divided by negative 16 over 3. Now when you're dividing fractions, that's when you multiply by the reciprocal, or copy, change, flip. So I'm going to copy the numerator, change to multiplication, and flip the denominator, so negative 3 over 16. And now we multiply. And when we multiply this together, 80 times 3 is 240. And 240 divided by 16 is 15. And it's going to be a positive 15, since a negative times a negative is a positive. So that is my x. And now I take this and I plug it back into my equation here to get my maximum area. Here I don't need the dimensions. The question is not asking for it. It's just asking for the maximum area. So I can just take that x is equal to 15 and plug it into this equation here that I have for area. So negative 8 over 3 times 15 squared plus 80 times 15. Now 15 squared is equal to 225. Plus 80 times 15, which is equal to 1200. Now when you're multiplying this out, this fraction, remember it's numerator, numerator, denominator, denominator. Negative 8 times 225 is negative 1800 over 3 times 1, which is 3. And you can actually divide negative 1800 by 3, which is negative 600. And negative 600 plus 1200 is equal to 600, and our units would be square feet. And that is how you maximize and minimize area and use the quadratic equations and quadratic functions in other applications.